3, 2, 1.
Welcome to
Herbert Junior Surface Grinder Part 5.
And in this one, it's mostly electrical work. I've finished the painting, so now we can have a look at the electrical circuits. Now you can see there that I've taken out the contactor and I need to replace it because it has a high voltage coil and I need one with a 240 volt coil. It's arrived, and surprisingly all the markings and the fittings seem to be just about the same. So we're going to dispose of this part and keep the thermal overload, and of course this is the new one here, and it says on the side here 220 volts 50 Hertz. These are the wires that go up to the switches on the top of the column, and I've refurbished this switch block here. This button I think was stuck in, but it was just with oil and rubbish. Now they're working perfectly fine. They're very nice switches actually. They've got inspection windows on them here. So we're wiring up one normally closed and one normally open, and they're looped together. But these have been wired out somewhere because these switches were inoperative. So we need to find out where this was looped. Probably that one, I'm guessing. I'm not an electrician. Don't copy anything I do. Now I tried using a couple of diagrams I got off the web. They weren't quite right for what I was trying to do. Also, these switches had been wired out. I wasn't sure how they'd done it. So I spent a lot of time, maybe an hour, trying to figure out, how to wire this from what was there already. In the end, I made my own diagram, ripped everything out and just rewired it. And I'm happy with it now. And it works from the switches. Just trying those switches now should be on, off, on, off. Right, I'm ready to test that now. On, insulated screwdriver, sort of, off. That's working. So I've got this thermal overload in circuit on the coil. Good. Bracket painted, conduit painted, fitted, flexible cable through, clamped at the top here, end of the cable. Now this isolator switch here, underneath it was originally grey. I like it red, so I've scraped all the paint off it. I've red lead painted it. Red lead? What do we call it these days? Red oxide primer, that's it. And I'm going to paint it red with just some red house paint I've got. So the next job is to mount this contactor switch up on the plate here. I've fixed the contactor to its base plate with nylock nuts to keep that safe. I've also added an earth bond strap onto here with a nylock nut as well. And the red cable is in, the blue cable is out to the motor. I've just put a spring washer under each of these nuts again just to stop the thing working loose. I can't imagine how it would, but better safe than sorry, isn't it? Not forgetting the gasket. Ask me how I know. Scene 1, take 2. Now whilst we're waiting for the paint to dry on the isolator, we need to think about how we're going to get our third phase, because we're supplying this from a single phase supply, and we need to refer to the work of Charles Proteus Steinmetz. Now it sounds like I'm just making that up, doesn't it? Here you are on the phone, it's true, Wikipedia said so. And we can use his formula to calculate the size of capacitor that we need to give us our third phase. Now the problem with the formula is, the fact of it is, that it's dependent on load, which means it's dependent on current. So Steinmetz connections are not great for machines who have a variable load. They're good for pumps and things like that. Anyway, the formula tells us that for the full load current for this motor, we would want a 20 microfarad capacitor. Now I've got a 14 here. When I bought the machine from Eddie, he did some tests because I had some questions for him, and he did some tests for me before I bought it. And he was running it from a 10 microfarad capacitor. Now maybe at this point I'll slip in a bit of video that Eddie sent me. I don't think he'll mind.
motor running, delta connection, Steinmetz connection. The value of the capacitor is 10 microfarad, 400 volts. L1 amps 0.9, L2 amps 0.6 and L3 amps 1.1, which is the capacitor phase. All running okay, no heat. Perfect.
Once I've got this wired up, and we'll put the oscilloscope on it and we'll see if we can see the relationship between the phases. Now, we're not going to get 120 degrees apart on each phase. It just doesn't work like that with a capacitor. But anyway, we'll learn something from it, I think. I've always wanted to do it, and that's what we're going to do. Well, things are on the move. I've thought about all the places in this room that I could put this machine, but this corner really is the best. So the sandblasters had come out. My son's coming round tonight to help me shift it. The paint that I've used on the isolator, the red paint, is taking forever to dry. So we're going to rig up something temporarily with the capacitor, get the motor on, test it, do some measurements and see what figures we get and compare them to the figures that I got from Eddie. Eddie had wired this motor in low voltage delta for me already. So you can see the 4 wires coming off, 3 phases and earth, come into this connector block. These are very thin wires feeding, but this motor, well, it's only for the test anyway, and this motor only draws 1.5 amps per phase in low voltage full load. Green is earth, the yellow is connected to neutral, the blue is connected to live or hot as some people call it. And then the capacitor is across live and here to create this phantom phase on the red. So if I go to the wall and turn it on, the thing I'm sure is going to run. Well, it was running. I'm going to have to check the fuse in that plug, it may be too low. Yeah, it was only a 3 amp fuse. Well, that's right for lighting cable, but not for this test. Remind me to put the 3 amp fuse back in when we've done. Did you see the dust come out? I think I did. Anyway, that's running. So let's get some meters and do some tests. So this is where I need a kind of dental assistant to help me write these down. So we're going to do blue to red. Blue to red. 262 volts. And checking current in the yellow, 1.1 amps. Now let's put an oscilloscope on, if I can rig it up that is, and we'll just look at the phase relationships. Here's a safety comment, pay attention. I'm going to connect that to a phase. I'm going to connect that to ground. That is connected all the way back through to earth on the line supply. If you connect that to a phase, you'll get a big splash and a horrible smell, and it could be the end of your scope. I'm not interested in the absolute voltages on the scope display. I'm only looking at the phase relationship. Be warned, if you want to go across 2 phases, you want a differential scope probe. This is just an ordinary ×10 probe. At the moment I've got this set up with one trace on red and the other trace on blue, and the capacitor is across red and blue. So we will see 2 waveforms to compare to each other, and we can see what the phase shift is across the capacitor at this side over here. Now the time base is set to 2 milliseconds per division, and 1 full cycle at 50 Hertz would be 20 milliseconds, so 10 squares. So 10 squares is 360 degrees, which means that every square is 36 degrees. If we compare, let's say there against there, that's about 2 squares. So the phase shift across that capacitor is near enough 70 degrees. Now in absolute theory you'd get 90. The amount of shift is going to vary according to the load on the motor. Now with the motor connected through the machine, it was spinning the wrong way at first, so you can just reverse any two phases on the motor, which is what I did. The paint on the isolator is still drying, so I've got this connected up just as before through that connector block. I can use the switches now on the top of the column. Now when you connect in the supply into the contactor, you have to put the single phase, live and neutral, or hot and neutral, across the 240 volt coil on the contactor. If you try to energize that coil from the fake phase, the phantom phase, it's not going to work properly. Well, this is the point you always come to where theory meets reality. You saw that motor start with the capacitor, but when I put it on the machine and put the belt on, it didn't have enough oomph to start the motor. So the capacitor's not right, and I do remember now that static converters often have a starter circuit with a bank of capacitors that come in just to start. But what I've done is I've wired it off my kind of general purpose inverter, and we'll put it on the machine and see if that spins up. And if it does, well, that means I've got to think about making a static converter. I'm doing this, you might say, why not? Why bother? You've got an inverter there. But I'd like to keep the original configuration with the contactor and the switches on the column. I can wire in those switches on the column with an inverter, but I've got to rewire it all. I'll need, if I do it with something like this with a plug on, I'll need more pins on the plug, and it's just a pain. I'd just like to see if I can make it work with the capacitor. Anyway, you'll hear it run, and that's just on the floor. I've done an RPM test and it's running at right speed, so we'll mount it on and see if it runs on the machine with the belt on now. 3, 2, 1. Well, there's nothing wrong with that motor, so at this point I'll tighten up the pulley on the back of here, check for the end float, and I'll grease up these bearings. We'll run it, see what that's like, and then we'll return to the question of the static converter. I'll put some work into that. If it's not going to work, I'm just going to have to go the inverter route, but I will try. People are often interested what grease I'm using. So Shell Gradus S2V103 NLGI3. I've already put some in here earlier, so just checking I've got enough. Greased up, I was still getting some noise on those bearings, and so I checked this end plate and I needed to adjust it because you've got to get the balance right on these 3 screws, and I'd got it slightly tilted over with one screw quite a bit tighter. But with it adjusted up, I think it's fine. I'll get some lunch and then I'll have a look through my box of bits, and I know I've got some capacitors and a relay and a few bits, and we'll have a look at this static converter idea. If not, I'm going to have to go for inverter. Don't worry about that. Later.
Welcome to
Herbert Junior. I forgot it. I need one. Again, take 2.
Welcome to
Herbert Junior Surface Grinder Part 5.